Today, let's discuss Hess law. It is impossible to determine some enthalpy changes experimentally because the reaction can't take place under normal conditions. For example, a reaction between carbon and hydrogen to form methane. For such cases, to determine the enthalpy of formation of the substance, that is, for example, methane, the enthalpy of combustion of individual elements forming that methane and that of the compound are linked with the enthalpy of formation in what we call energy cycle diagram. So the energy cycle diagram will involve connection of combustion of carbon and hydrogen, combustion of the compound formed, that is methane, and that will help to know enthalpy of formation of methane. For instance, methane burns to produce carbon dioxide and water, and the constituent elements of methane, which are carbon and hydrogen, also burn to produce carbon dioxide and water. So the Hess law will really connect them to form the methane. That is looking at the enthalpy of formation of methane. When we say that individual elements burn to produce carbon dioxide and water, then what we simply mean is that carbon as one of the two elements burn in oxygen to give out carbon dioxide. Then hydrogen as well will burn in oxygen to produce water. The three enthalpy changes can therefore be illustrated in an energy cycle diagram as shown below. So we have carbon plus hydrogen giving methane, CH4. This is delta H, formation of methane. Carbon will burn to give carbon dioxide gas that is burning in oxygen. Hydrogen as well will burn to produce water. And remember, methane undergo combustion to give carbon dioxide and water. So this is delta H combustion of methane. Then the middle one summed up will give delta H combustion of hydrogen and carbon. Let's call this delta H1, delta H2, and delta H3. Using vector concept, it is clear that to obtain delta H1, then is simply delta H2 minus delta H3. That is the reverse, the opposite. That's why we talk of the word minus. Now, it is necessary to realize the individual elements forming up the compound first. Then you will easily come up with an energy cycle diagram. From the diagram above, there are two ways of obtaining carbon dioxide and water. The first way, combustion of individual elements, that is carbon and hydrogen. Secondly, there is combustion of methane, and methane will also undergo combustion to produce carbon dioxide and water. Again, this will bring now connection of the three, in that delta H1 is equals to delta H2 minus delta H3. That is what connect the elements that we have in the energy cycle diagram. Well, this method of indirectly determining the enthalpy of formation of a compound is based on Hess law of constant heat summation, which states that the energy changes in converting reactants to products is the same regardless of the route by which the chemical change occurs. Route by which So, formation of methane can pass through combustion of individual elements, then leading to also combustion of methane, and that connection brings a way of determining the enthalpy of formation of methane. Back to our energy cycle diagram. To balance this, we have 2 moles formed, and we can require a general 2 moles of oxygen in the reacting vessel. Examples. Let us now start to calculate the different H values. Examples. You want to try to do as many as possible so that we get to understand all to do with the Hess law application. Number 1. Given that carbon plus oxygen burn to produce carbon 4 oxide gas, and delta H for that is negative 393 kilojoule per mole. Hydrogen alone burns to give out water. Delta H is negative 286 kilojoule per mole. Methane will undergo same combustion, 2 moles of oxygen gas required to form carbon 4 oxide and water. Delta H for that is negative 890 kilojoule per mole. Question A. Write an equation for the formation of methane from its elements in their normal physical states. At standard conditions of temperature and pressure. So the equation is as follows. That is carbon plus hydrogen to form 1 mole of methane. Part B of the question: draw an energy cycle diagram for the formation of methane from its elements. Or simply, draw an energy cycle diagram that is going to link formation of methane. You can write that. Draw an energy cycle diagram linking the formation, delta H formation of methane and delta H combustion of methane, and that of constituent element. So that gives carbon plus hydrogen gas leading to formation of methane. That is delta H1 carbon undergoing combustion to form carbon dioxide. Then hydrogen will lead to formation of water. Then we have methane undergoing combustion. That's what we call delta H3. This is delta H formation of methane. Then we have delta H combustion of carbon and hydrogen. Energy cycle diagram. To balance up